Hi, I'm Shan Gao, philosopher of physics at Shanxi University, China. I mainly do philosophy of quantum mechanics. So this semester, I'm visiting the Center for Philosophy of Science, University of Pittsburgh. During my visit, I plan to write my next book about the philosophy of quantum mechanics, celebrating the centenary of the theory. So quantum mechanics is no doubt the most successful physical theories in the non-relativistic domain. But there are still two fundamental problems in the foundations of the theory. The first one is the meaning of the wave function. Is the wave function ontic or epistemic? If the wave function is ontic, what physical state does it represent? The second problem is the measurement problem. When assuming the wave function is a complete description of the physical state, then the Schrödinger equation and the Born rule are not compatible. There are, in general, four ways to solve the measurement problem. The first way is non-realist. It denies the reality of the wave function. One example is cubism, also called it quantum Bayesianism. The other three ways are realist. They admit the reality of the wave function. They include Born mechanics, the many worlds interpretation, and collapse theories. Then which solution is the right solution to the measurement problem? In my view, we need to first find the right interpretation of the wave function. Can we finally solve the measurement problem? In my previous book, The Meaning of the Wave Function in Search of the Ontology of Quantum Mechanics, I propose a new interpretation of the wave function. I argue that the wave function is not a physical field, but a representation of the random discontinuous motion of particles. So, if this interpretation is right, then I think we will have more resources to solve the measurement problem. First of all, Born mechanics, I think, may be the first solution we can exclude. I know many Burmese may not agree with me. The first issue of the Born mechanics is the quantum equilibrium hypothesis can hardly be justified. I think a more serious issue is that the Born particles have no causal connections when they are in an efficient product state. For example, in a measuring device or in our brains. So if this problem can be solved in a satisfactory way, I think Born mechanics may be not the right way to solve the measurement problem. The next solution, collapse theory, I think maybe not the right way either. The reason is that due to the tails problem, collapse theories imply ontology of many worlds. In this sense, the collapse of the wave function might not help account for the Born rule. So I think the many worlds interpretation might be the right way to solve the measurement problem and maybe the right interpretation of quantum mechanics. So long as it solves its two main problems, namely the problem of ontology and the problem of probability. Here, I think my new interpretation of the wave function in terms of random discontinuous motion of particles may help solve the two shiny problems of the many worlds interpretation. First, the particles provide variables for the many worlds interpretation in our three-dimensional space. So this picture of reality may be more satisfying for the opponents of the many worlds interpretation. Next, as my recent research strongly suggests, the random discontinuous motion of particles may also help solve the problem of probability for the many worlds interpretation. If this is true, then I think the many worlds interpretation may be the right way we should pursue. Albert Einstein once said, the most incomprehensible thing about the universe is it is comprehensible. I also think so. I believe we can finally understand quantum mechanics and find the real picture of quantum reality. That day may be not too far. Let's wait and see.